want to do the molecular docking, then the basics we have learned that semester second and form. Whenever a substance which binds with the protein, certain amount of energy will be liberated. Can calculate that energy, can give some amount of possible docking score that, and we can also study various interactions. So first of all, we shall start how to set up the AutoDock. So we search on Google how to AutoDock. So this is basically you get this link. I mean, you click on that link. AutoDock software which is provided by Cripps Research Institute. So that will open. Go to this downloads. On the downloads, here you will find AutoDock. So if you fill up the once you fill the registration form, then you can proceed to the download page. Download page, here you can get the link for installation of AutoDock. I mean, for our Windows system, if you click on that, automatic download will start. We can download this Windows-based AutoDock version wherever in the system. So I have already downloaded it and have already installed. So I'm not again going to download the same. So this is basically AutoDock version 4.2. And also we need to download certain other tools. Because AutoDock as such it will not work. We will require some other tools such as if you search on Google NGL tools, website again of Scripps Research Institute, that will open up and it will be like this. From here also downloads, you have to go to downloads, Windows based version that so we can download that MGL tools 1.5.6. MGL tools will be required to run the AutoDock. So that I have already downloaded. Yes, I'm not again going to download it. And some other tools are also there, such as BioVia Discovery Studio that is also required to operate this OpenWebel, which is another software. All the things are available on Google. Search OpenWebel, likewise 4.1. Site will open up and you can similarly, a software visualizer such as PyMol can also download. It is a free version. Okay. Search on Google PyMol, so you will be able to. So now let us start. How should we proceed for our molecular data? So first, tell you how should we select go on demonstration of AutoDock, demo of AutoDock. So for this time being, I am going to work on this protein 1T-LH. We should start from anti-cancer agents. So this is basically deposited in the Royal Society of Chemistry. If on Google, if you search like RCSB, ADB, so this is one of the collective organizations of so many protein data banks, or protein data. We have
So
been
sorry to
deposed.
interrupt. So,
Hello, hello.
yes, sir.
Bolo, what was the purpose?
सर एक्चुअली पाइमोल आपने जैसा बोला था, मैंने डाउनलोड करने का ट्राई किया, बट इट डिडंट इंस्टॉल.
Okay, then after this meeting, you let me know and share the screen. I will help you for installation.
ओके सर.
Okay. So this is one of the website of RSCB protein data bank. So this is here we can search by giving the name of the protein or by giving the four-letter amino acid code. Do that, we will get that protein. So here I am searching 1PL. So I will go to the same website which I put a couple of minutes. So this is that protein. I am clicking on that so that I can go to the next page of that. So here, if we go for downloading the file, so I am clicking on that. There is option call over here. Download the files. Click on that. Download using PDB format. I click on going to a specific folder on my desktop. Doc file. So then I am saving that protein as a simple name. 1PLA complete protein. So that now has been downloaded. Now I will go to I will have to delete because what sir here delete the ligand which is present in what is basically these proteins are what they are just like a kind of crystallization what we are doing in our organic chemistry lab. Putting the reactions, we are finalizing our products, finishing our products after that the end of purification, either by recrystallization, we are getting the crystals. So if that is a small molecule, so then definitely the crystallization is also possible for larger molecules such as proteins, peptides. They are complex with certain ligands or are complex with some amount of inhibitor. So this is also a kind of inhibitor, human DNA topoisomerase, and it is complex with indino, isino, isoquinoline, AI 352. That is also complex with the duplex. So this is basically a inhibitor. But DLate is one of the human topoisomerase 1 protein always. So, all the things have been provided. We can also see just below it that it is complex with AI3, it is indinoisoquinoline. This is the structure we have provided. Click on 2D diagram, 2D diagram of that inhibitor. So before we start our docking, the protein has to be processed uh, with certain extent, such as deletion of water molecule, addition of hydrogens, and addition of charges. So these are the important criteria. Why? Because uh, once the after crystallizing a protein in lab, if it is subjected to XRD or X-ray diffraction and protein and proton NMR, then it is not a processed protein, just a raw protein. Have to convert this raw protein into protein which is suitable for molecular docking. That's why the first step is required. I'm going to open PyMol and will show you that how we can delete the ligand from the protein. Already like this is a complex of a ligand with protein. So our objective should be first of all we should delete the ligand and then we should uh, uh, process the protein. So for the deletion of the ligand, what I'm doing, I'm opening that PDB file and open. Going to my directory where I have saved the protein, going to that, one DLA, I will ask to open the same. So this is the protein, very nicely it is available, beautifully presented. That the DNA is there, alpha sheets, beta sheets, helical structures. Okay, so this is basically a kind of our toolbar, side toolbar, here where my cursor is there. Okay. If I click on this S, so basically this S, which is here where the cursor is located, so it is a symbol of sequence. I click on S, so sequence of the protein will appear. So this is the protein 1TL8, that is a four-letter code for this protein. See that also. And here, these are the various number of amino acids. So basically, how should we derive the first letter code? Here it is Q. So Q is for glutamine. That is 201. The second amino acid is K. So once I am selecting this K. So K, where is the lysine is there, which is highlighted the workspace. So this black portion, that is also called as workspace. This W, that is again another amino acid. So that is third amino acid. So that is basically tryptophan. Tryptophan 203. This is Q is 201 and K lysine will be 202. W, that is tryptophan, that is 203. So how can we identify? We have to look at this. First, 256 is here, another amino acid. I'm checking this, so it will not be displayed in the workspace. This 251 is that. So उसका जो initial left letter है 2, so that 2 is vertically aligned with P. This P will become 251. So this way we have to identify the amino acids that. And similarly here 276. So this again lysine here, that will become 276. This will become 277. 278. So likewise, the whole chain of the protein can is a huge chain. There are nearly 770 amino acids. 765 amino acids are present. Right? More than
Sir, how
500.
would we know which amino acid is denoted by which letter?
That is basically if you refer biochemistry by Satyanarayan. So there is in that there is a dedicated unit of proteins, peptides, in which it is there that there are different 20 standard amino acids. So there
Yes,
are
sir.
three-letter code for amino acid as well as one-letter code for amino acids. All these are one-letter codes for the amino acid. Bioorganic biochemistry by Satyanarayan. So this can identify the amino acids that is universally accepted one-letter code as well.
Okay, sir.
And these are other also. Basically, these are DNF, nitrogenous bases. Nitrogenous bases of DNA because since it is a cancerous protein isolated from human, it's also complex with deoxyribose. There is this A, G, C. These are the various nitrogenous base. A stands for adenine, C stands for cytosine, T stands for thymine, G stands for guanine. These are the other nitrogenous base present in this DNA. And after this, if you move this arm, this side arm to the extreme end, then here we will find AI3. This AI3 is nothing but that is our this inhibitor, isoquinoline. So I have selected it. So what I will do? all these things. We delete it. So now it is AI3. I have selected. So you can see it is highlighted. The workspace. Now I will select here. There are several buttons: action, A for action, S for show, H for hide, L for uh, ligand, sorry, L for label, and C for color. More you will work with this software, play with this software, you will come to know about the features of this. What I am doing now, I am labeling, I am zooming it, uh, T, and with the help of mouse controls, and moving it by the left click as well as drag. This is the ligand located in the cavity of the enzyme, cavity of this DNA topoisomerase. So now, uh, we will do, we will like go to action. Our objective is we want to delete this ligand from this protein. We want to convert a single protein file, PDB file, to two different PDB files. One is of protein, one is of ligand. So how can we do that? So for that, I will go to this option. I have selected my ligand. I have went to the caption, copy to object, and will mark as new. Now you can see it is divided in two portions. Earlier it was a single line. Now it is so now from I will go to my ligand this objective. Object is already there. I will select this. First one. Okay, let me delete this. So I have selected this. It is selected here. I will go to option delete selection. So it will delete my selection. At the end, is there any option called delete? Remove that option. So if I click on that, it is deleted. So I have deleted my this ligand because now this AI is not visible anywhere in the ligand. So I could successfully delete the ligand from protein. So next I will save it. So I will go to export molecule and export it. Selection is enabled. I will click on the original atom order so that nothing will be disturbed according to the rank. We save it as PDB format. So .pdb, which stands for protein data bank, I will label it as my target. So target.pdb is the extension .pdb I have given recognized it. So now I can again close this. So if I go to my trial menu, see I have downloaded, I could see my target. It is of no, it is void of this inhibitor, free from inhibitor. So I also need this inhibitor because I want to demonstrate, or else what I can do, I will show it to you later. Some different. Fine. So now it is the time to run AutoDock. Go to AutoDock option, AutoDock tools. I installed it previously, so it is working. It will show the loading as well. Okay. This is AutoDock Tools 4.2. So with 4.2 tools, we are working on. Now, here there is a menu called File. So, in File menu, first we will go to this Preferences. Suppose just it is to change our working directory. We will set the preferences. Here my directory is something different. I will delete all this startup directory under this. I will go to my trial, will put my cursor. So whole path C users HP desktop doc trial. I will copy it after selecting whole, go to Autodock, will paste. Fine. So this is startup directory. I will make it default as well as set. So I have set my directory as the trial. Now why we have to set the directory like this? Because this Autodock will generate so many files. We have set the startup directory specific folder. Our all the files will be stored in a one computer or one file or one folder only.
So for every new target, do we need to do all, this startup directory?
For all the times, whenever first thing whenever we open the Autodock, at our preferences for running any calculations.
Okay. And sir, always uh, do we need to remove that ligand from the target?
Yes, that has to be deleted because we instead of after deleting that ligand, we want to dock our compounds instead of ligand. So
Okay.
interaction of it is already protein is already occupied with one ligand. We want to dock our compound, then we have to delete the ligand first. So that is necessary.
Okay, sir.
Right. So now next we will go to file feed molecule. Feed molecule is another option. Then we will go to this target. I have deleted my target from that. I will ask to open it. Once it is open, it will look like this. So here, like we'll zoom, so you can see the certain mouse control and moving the workspace. Left, left, right click followed by drag. So this is here we cannot find our ligand. So how we should plan next? We will this is our already protein. We will go to edit. We'll delete the water. So we will delete the water first. Now why we require to delete the water? Just like our organic compound, this is also organic molecule. Our compound after the synthesis may have some amount of moisture, little amount of moisture. We run our sample after in this rota vapor, then we can remove the sample water. Then it is free from moisture. प्रोटीन के लिए भी वैसा ही होता है. Also some water of crystallizations sometimes may be present in the crystals. During XRD, these waters are to be observed in a huge macromolecule such as this. So that's why we need to delete the water molecules also. Unless and until a specific water molecule is showing some interactions in the active site, then we should not delete it. Otherwise, all the water molecules should be deleted. Autodock does not allow to delete the specific water. Schrodinger software, Maestro, which allow us to delete the specific water. Autodock, we, by forceful action, we will have to delete all the water molecules. That we can delete by going to edit and delete water. So task one after importing the protein is water, right? because we are not interested in water. It may be water of crystallizations or found during this crystal formation of a protein with ligand. Water is not of. Then we need to add the hydrogens. So I will go to edit hydrogens and will ask add. Why we need to add water? So why we need to add hydrogens? So there is a reason. Reason is X-rays are the powerful radiations which are used in XRD, and they have certain wavelength, corresponding amount of energy. X-rays are the powerful radiations which can cross even our bones also. Definitely, if they can cross the bones, nothing difficult to cross them, such polypeptides also. So our objective shall be that these X-rays cannot distinguish where is the hydrogen. Hydrogen is a small atom, the smallest atom on the earth, 1H1. So X-rays cannot detect the hydrogens. That's why whatever the information what is derived from protein data bank does not include the definition of hydrogen. That's why we need to add hydrogens. We will add hydrogens. And here we are not interested in adding all the hydrogens. We are only interested in adding the uh, polar hydrogens, which are attached with oxygen, nitrogen, sulfur, or other electronegative atoms. These polar hydrogens can form hydrogen bonds. And that is one of the key import interactions which is required for showing the reactions with ligands or the enzymes or our compounds. So I have selected here polar only. Other data, other informations are by default as such. I'm not going to change. I'm just clicking OK. So now you can see the hydrogens have been added to this nitrogen or to this oxygen. Earlier it was not, but now it is there. Second step is addition of hydrogen. The third step is addition of a charge. So we will go to again edit charges and add column and charges. So this addition of column and charges is required because this is a maybe this is a chargeless protein. So this column and charges which are required. Once we click on this, the charge will be applied to the whole protein. About this among this much value of column and charges. Just like we have proved positive charge, negative charge. So depending upon uh, tertiary nitrogen, quaternary nitrogens, carboxylate, oxygen ions, so charge has been added to the several uh, amino acids that are present in. So this is the addition of the charge. Once we have added the charges, then we have to go to grid, macromolecule, and open. Or yes, so what we will do, not open, we will go to grid, macromolecule, and choose. So here there is a window open which has select molecule. We will select the target. We will click on select molecule. Once we have a click on select molecule, it will ask a warning like this. Click on OK. It will ask us to save the file in .pdbqt. What is the meaning of Qt? Q means charges. Coulombic interaction with Q1, Q2, you might have studied in your plus 1, plus 2, 7th or 12th. So that Q is a kind of charge and T is other processes which we have done, such as addition of hydrogen, removal of water, etc. That is a process protein, so we can save it as PDBQT. PDBQT is the extension for. Now I am going to save. The moment I save, the color of the protein will be changed. You can see the color of the protein is changed. That indicates your protein has saved once your the color is changed. So up to this, I hope it is clear,
Yes,
preparation
sir.
of the protein.
Yes,
I hope that also
Yes, sir.
you, whenever I'm explaining, you make a copy of the, make a notes with you. Although I will share the PDF with you essential for this, so you will also go on noting the commands. Your
yes, sir. I'm already noting.
so once we have prepared the protein, then next we will go to ligand. So there is one option just beside this. Now we have prepared our protein, so we have to prepare our ligand. So here in AutoDock, it will allow the only entry of this .pdb file, protein data bank files. What to prepare the protein data bank files, we have to select certain. So I have opened my our Camdro, that is uh, one of the another software which is essential for this. I'm drawing some structure here. So I will draw certain important structures of my choice. From as all molecule at the substitutes, drawing molecule like that. That has green as well here. We'll add some substituents on this. Like, and then so at this position, let me label it as nitrogen. Selected the whole structure and by pressing I am cleaning. So now I have selected it, Control plus C, copied it. We'll go to after drawing in CamDraw 2D, I will open the CamDraw 3D because I have to convert this two-dimensional structure into three-dimensional. Here that is also two-dimensional platform. Draw is this way. You can also convert it into. I will paste copied structure into that. So the structure is on the workspace of Cam. I will select the whole molecule. We'll go to structure cleanup. It's already clean up because I have cleaned up from my Cam 2D. Then I will go to calculations MM2 and minimize the energy. Let me give this command first and I will explain why it is required. So whatsoever the default parameters, I am minimizing the energy run. Now it is minimizing the energy and it will undergo some changes in its orientations or alignment. It should deal with minimum energy structure of the backend so that we can achieve the best score. So you can see some amount of iterative cycles is continuously going on. Minimize the energy of molecule, although it is a big molecule, some big, small molecule, not a too much big. Iterative cycles are continuously going. Minimize the energy of this one. So it is now completed. I go through this, then we get this much amount of kilocalorie. Okay, we are not interested in energy, so we will select file save as. So save. I will go to my document file and label this as my ligand. And let me put Now, since we are learning this computational chemistry, so we should take all the care that whatever the name we are giving, we should not give any space in between two words. Like if I have given the space like this, so all the words are continuous and not giving any space in between the words. Desktop is together. There is no space in between desk and top. To give the space in your doing AutoDock, and you will not get the results. You will end up in errors. That's why in naming the path, in naming any file also, avoid giving the space. Instead of the space, we can use like this underscore or the dash that we can use. This is one of my experience, so based upon that, I am sharing that information. Okay, so now we have drawn one ligand. So we will import that ligand. Why? Because Autodoc only accepts .pdb files. So we have prepared dot routine data bank files using M3D. So then we will go to ligand, put open. We can input our ligand by changing this to PDB files. So this ligand is now visible. I will click here, open. So now this ligand is available in the workspace. Check it. Yes. Zooming it also from my mouse pad, show you the ligand. I hope that it is visible. Fine. So this is ligand. Uh, Here for this ligand, I will select torsion. Then we'll select this root. So before I select the root, I can request you to look at this workspace where my molecule is there. Now I'm clicking on detect root. So you see what change is there. I will click on detect root. You see this has been generated green dot ligand. Previously it was not. Now it is. So that is what so called as detect root. Okay. So this is one of that information ligand detect root. Then I will again go to ligand torsion tree and will select here number of torsions. So for this molecule, these all are the green bonds which you can see 1, 2, 3, 4, 5, 6, and 7. So these are the 7 bonds which are green in color. They can undergo torsions, they can undergo rotation across the two planes, torsions. That's why there are 7 bonds. We can restrict the numbers by giving 6 and 5, 4, etc. We will select up to 7. The more number of the torsions will be there, more number of conformations will be generated. So this is a molecule which is having 7 torsions, 7 green bonds, which indicates they can undergo rotation, undergo torsion, torsional change. Okay, once we have defined these torsional changes, we have to out select the, we have to specify the aromaticity of these carbons. So we can go to ligand, aromatic carbons, aromatic criterion. So we will select the aromatic criterion 7.5, which is as default. We are not going to change. We will again go to output, and this is our second task is now completed. That is output file. and to save it as PDBQT. So this is my ligand file. I will give the name as dot PDBQT. You can see I gave the name. Now I am saving it. Okay. So now this ligand is saved. So my two tasks are completed. Preparation of a ligand dot PDBQT. Second is preparation of protein or target dot. These two tasks are completed. Now, after this, once we have completed this, we have to prepare the grid. What is called grid? Grid is basically a kind of box where we are going to dock our compounds. We have to specify because this protein is a huge molecule. We have to specify, we have to ask AutoDock that you dock my compounds in this range only. Not here, not here, not here, not here, but specifically here. That is what the use of grid. और जितना बड़ा आपका ग्रिड होगा उतना ही कंपाउंड आपका कहीं भी जाके बाइंड हो जाएगा. दैट्स व्हाई ग्रिड शुड बी आल्सो स्पेसिफिक. ऐसा नहीं कि मन में आए वो ग्रिड साइज बना के ऊपर लंबा चौड़ा ग्रिड बना के डॉकिंग कर. Grid should be as much as it should cover the where the ligand is going to bind, cover the amino acids which are important as active amino acids, should be important as it should include the active amino acid residues as well. So this we can select using our grid. We will go to grid. We'll open up this macromolecule. Already we have done this one time, so we will select choose. We will select target. Then we so I think we have already done this thing, so that is not required. Already we have saved it previously. Protein.pdbq. That's why it is not. Second option is set map types. We select on set map types. Then we will select this choose ligand. I will select on choose ligand. It asks me to select my ligand from. I will select the ligand. So now my ligand is also selected for molecular topic. Next, we will select grid box. So the moment I click on grid box and see on the workspace, this box is available. Giving some attributes using mouse. Okay, so you can see the grid box is available. So here we can give that send go to center, center on ligand. So basically it is consider this is my ligand and okay. So what I have done previously I have checked that this AI3 indenoisinophenoline is going to bind and what are their interactions. So this I have done previously. So this we can I will straightforward introduce this data here. Otherwise, we can also manage also. So you can see moment I go on changing this numbers, there is a change in. My objective is I want to set the grid box where ligand was bound. That I can ask my compound to bind at that place only. This predefined I am taking, so as we can also generate a new grid also. But as of now, just I am going to type this I previously identified values. save my time. Otherwise, this also requires time. 1 - 1.7, right? And -4.32, that is y-axis. Then 27.85. So in this is 3.37. This is as same as the previously identified one. It should be common throughout our document. So here actually the ligand was bound. You can see now it is sufficiently uh, big grid box where my compound. And you see that grid box which is having x, y, and z dimensions. X is red in color, y is green in color, and z is blue in color. That is red, green, and blue. RGB color code used for this protein. I hope this is sufficient enough grid to dock my compounds. Okay, once we have set these parameters, then we should click on this file, close saving. So once we have closed it, our grid box will disappear. So I can check whether it has been saved or not. So again, I will go to grid box, click on grid box. I can see that my grid box is saved. Now I do not need to resave it. Okay, so grid box is that. Then next I will go to output and will save my file as GPF. What is GPF? Whatever the parameters I have given as a form of grid that I have to save it. That I can do using a.gpf. A is a simple file name I have given. Simple a.gpf. That gpf means read parameter file. I repeat, read parameter file. Then I will click on. So now my grid parameter file is saved. Next, I will go to this docking because once my grid is ready, my ligand is ready, my protein is ready. I can go for docking. But I will have to say AutoDock. What are the parameters through which I can do docking? So I will go to macromolecule I will have to choose because I will have to tell AutoDock this is my macromolecule. I will go choose docking macromolecule choose. So I will open this ligand. Sorry, I open my target as a macromolecule. Since I have to select my macromolecule. That okay is saved. So once it is saved, I will save it as e dot. I do not have to save it, but docking macromolecule. I went to grid, not to this set rigid file name. So I will have to. लास्ट टाइम मैंने मिस्टेक कर दिया था मैंने ग्रिड पे कॉल ग्रिड पे क्लिक कर दिया था ठीक है ऐसा हो ग्रिड में भी मैक्रोमोलेक्यूल है और डॉकिंग में भी मैक्रोमोलेक्यूल है आई हैव टू सिलेक्ट डॉकिंग मैक्रोमोलेक्यूल that rigid file name. So this is the correct one. Our previous was the mistake. We have to click docking macromolecule set rigid file name. We will click here target.pdbqt, which we previously see. So that is target.pdbqt I have asked to as a macromolecule. Then ligand, we will go to docking, ligand, and choose. So it is already there in our workspace. I will select my ligand required for docking. I will select it also. So these are the parameters for my docking purpose of active, which we have already sorted. I will set them as well. Then we'll go to docking search parameters. This is important one because what should be their search parameters to search the different conformers. We'll go to docking, search parameters, genetic algorithm. We'll click on it. So this will open up genetic algorithm parameters. Moment I click on it, you can see various parameters are here. I'm not going to change them as such they are default. But the more I do the docking, if I feel that I want more populations, more genetic runs, etc., I can change. We are learning preliminary docking. How to do the docking that we are learning? We will learn first with fault parameters. We will accept it. So next, after this docking, we have selected search parameters, genetic algorithm, then we'll go to docking parameters. These are again defaults, use defaults, so we will use them. Can also customize depending upon our requirement. But as of now, we will go with default parameter. Next is docking output. So I will select this Lamarchian genetic algorithm 4.2. That is widely used. There are other also tools. So we will use this one. And I will give my file name a.epf, docking parameter files. I will save it as my directory. Now, up till now, is there any question? What is something there? You can ask the question if there is.
No, sir.
Okay. So now it is the time to run the AutoDock. Our protein is ready, ligand is ready, grid is ready. We should run the AutoDock. Before we run the AutoDock, I would like to suggest that in our directory where we have saved all the files, these four files should be AutoDock 4, AutoGrid 4, ad1.bound.dat, then ad4 underscore parameters dot dat. So these files should be there in our folder. How can we get these files? So from our C drive, if we go to C drive, where if we have installed this, then we need to go to program files, Tips Research Institute, and AutoDock 4.2.6. These two files you will find there. AutoDock 4.exe application file, AutoGrid 4.exe application file. So you will find there in your C drive once you have installed the AutoDock. Simply I have copied them and have pasted here and trial folder. This is required, otherwise AutoDock will create some problem. These two files, where do we have to get it? So if you have installed NGL tools in your C drive, so again I will go to my C drive, program files, 86. Here there is called NGL tools 1.5.6. You have to click on it, go to this uh, then site packages. Then in the site packages here there is called uh, Autodock tools. Autodock tools in which these two files you will find. 841 found.dat series parameters.dat. So simply I have further copied them and have pasted into my this thing. So I have four the files together. Okay. So that you should once you install NGL tools, once you install AutoDock, these four files will be your in C drive. You have to copy these four files from your C drive to your docking directory. Okay, once it is done, then again go to your AutoDock, run, and ask the computer to run AutoGrid. Okay. This another run AutoGrid will open up. Our working directory is already set. Program file name, I will browse it. I have to read first, first of all. So I will select this application which I have copied from my C drive. AutoGrid 4, I will open it. So you can see .exe file is given the path name. Since it is AutoGrid, so I will open my a.grid parameter file, a.gpf, which is in my trial document. So I will open it. Once I have clicked, my parameter file name is there, its path is there, and log file name is also automatically generated. TLG is grid log files. Wherever the something is being generated, that is called log files, output files. Then I will simply click on launch. Once I have clicked the launch, AutoDock is running. So it is in process as of now. And we can see in my trial documentary, several maps files being generated. Okay. So it is still running there. Once it is completed, then I can proceed for my next part. Okay. So let it be run for some time. It will not take more than 5 minutes. So meanwhile it is running, you can ask your questions. We can solve them whatsoever your doubt is. So any questions? Okay, now sorry, we will have questions later on because it's already done. So how it is completed, we can ensure is GLG file. Sorry, not read log file, GLG file. So I can click on right click on it and open it. It will open in WordPad. I can go to the end and you can read here. It is successfully completed in how much time? Near about less than 1 minute, 49 seconds. Okay, and since it is grid file, it is not of our much interest. We are much interested in our final docking file. We will again go to run AutoDock. Once we click on run AutoDock, this will be generated, and then we can. I will select on browse. We'll select this time AutoDock 4 application file of this much size. We open it. So I have given my program file. Next, parameter file name, since it is docking, I will give docking parameter file. We'll click on it, docking parameter file, open. So it will automatically give the file name to my generated output file, log file name, a.dlg. The DLG stands for docking log file. Previously it was grid log file. This time it is docking log file dlg. I will again click on launch. So it is now in there in process, and definitely each molecule it will generate 10 ligands and 10 conformers. So will take a lot of time. Fine. So this is the final step of docking. After that, there is we will have to analyze our results. So now the session is open for question answering from both of you. If you have any doubts, you can ask the question.
Sir, I've installed the AutoDock already, and
Yes.
as instructed by you today, I will follow the steps, and
Hmm.
then I think we'll have some problem and we'll ask.
Right. So have you downloaded NGL tools?
Yes, sir.
So is it
Sir,
installed?
I just checked the C drive, but I didn't find any files like you said.
No. Has it been installed? NGL tools 1.5.
Yes, sir.
Let me show this, then I will come to that. Because,
Okay, sir.
or else in between you can share your screen. Not an issue. And
Okay,
opting
sir.
might be present. Share your screen.
So here is the AutoDock that I have installed. Is it visible, sir?
What is next? What is the issue?
Yes, sir. I couldn't find the file that you said in the C
Hmm.
drive.
Okay, go to
Yes,
your
sir.
C drive.
Yes, sir.
Program files. Then You see MGL tools 1.5.6,
Yes, sir. Yes, sir.
and in this you click on it. Yeah, double click on it.
Yes, sir.
So now you will see LIB, lib, library, LIB. Yes.
Yes, sir.
Now go to site packages
Yes, sir.
and AutoDock tools.
Yes, sir.
Yeah, so here, yeah, आपके जो पेज है ना ED4,
Yes, sir.
both the files are there, right?
Okay, sir.
What you can do, you can copy them and can put in a separate file folder where you want to do the docking.
Okay, sir. Fine.
And that other two files you will find in program file, research institute.
Okay, sir.
Yeah.
Yes, sir. So the next question is related to Pymol.
Yeah.
Like,
So again, what is the issue with Pymol?
sir, I've tried to install this.
Hmm. Okay.
Yes, sir. So how should I start?
Hmm. So that is the one you have installed from
Yes.
your downloaded from computer system.
Yes, sir.
Let me check my library. What is something new? Pymol. No, with me it is something different. Different version. Is only a single file. वो दो भी है पहला वाला भी है अभी का वाला भी है. I have downloaded on 12th August. So it is different one. So go to Google. Can you access Google?
Yes, sir.
One in type Pymol.
Okay, just a minute.
Search. Hmm. Click on this Pymol downloads.
It is the registered one.
Sorry. Go back. Click on this pymol.org. Pymol.org. Yes. Involved by Schrodinger. We are uh, go down, download now. Is it mentioned? Windows based version. Yes. So I hope it will download now. Save wherever you want to save it.
Yes, sir.
Right. So I think it is 304 MB.
Yes, sir.
Downloaded the same file on 12th of this month. So it was an also approximately 311 MB. It was a
Okay.
single file, not a RAR file. So I hope that same will be case with this.
Okay, sir.
I think it is .exe. It is single file only.
Yes,
You
sir.
will be able to इंस्टॉल पाइमोल यूजिंग सेम पुराना वाला जो है उसको आप डिलीट कर दो
Okay, sir.
ओके एनी अदर इशू विद दिस
No, sir. And sir, Schrodinger is not getting installed. इसमें कुछ फाइल ओपन नहीं हो रही है.
हैव यू कंप्लीट डाउनलोडेड द होल सेटअप
Yes, sir. I've tried.
सो वेयर इज इट
Just hang हो गया है. But sir, will it? I will try it again today, and will come to you tomorrow regarding the same.
फाइन सो यू स्टॉप योर शेयरिंग सो दैट वी कैन डिस्कस द रिजल्ट्स दैट देयर
Yes.
ओके सो नाउ द रिजल्ट्स ऑफ दिस yes so the results are out here this is completed so how can we cross check results are completed I will go to my trial document trial folder and in that a different file is generated name is glg file a.glg
Yes,
this
sir.
that is gridlock file so this gridlock file we can open it we'll open in wordpad and if we go to the end so it is mentioned that this is now uh, successfully completed right? You can see here it has taken this gridlock file sorry we do not have to open gridlock file we have to open docking log file .dlg file so I will right click on it open word and with Microsoft Word we'll go to the end and we'll check is successfully completed and yes successful completion this is required otherwise sometimes it may not be it may end up in error we need to check before we proceed. So now it is completed. What I will do, I will search RMS. So check how many poses has been generated and what are their documents. This is its RMSB table. You can see these are the four major, sorry, these are the confirmed 10 different poses which has been generated to 10 different runs. These are their binding energy. The highest binding energy is minus 9.67, is obtained in fourth confirmation or fourth run. Okay, so this is the energy of our dock compounds against this. This will be required for judging the molecule whether it is good molecule or not. So now next is we after once we have this minus 9.67 kilocalorie per mole, have to go for kind of pose generation. How to generate the pose for a molecule using pi mole. Okay, so what we will do, we will run, sorry, we will analyze, go to analyze, dockings, open. We have to open here our TLG file, docking log file. It is mentioned here, docking log file. Open it, and since it is already ligand, so we'll give the new name ligand dash 2. 10 different poses confirmations are now ready. Then go to analyze. First, we have to select our macromolecule. We will choose it. It is already there in our workspace as a target. We select it and we'll analyze it. Then we will open the macromolecule. Sorry, अब तो हम कर चुके हैं. So now we will go to confirmations. Play. Moment is there. Play is there. I will select on this end button. After it is selected, another window has pop up. I will select show info, and so another window will open up like this. So after, this was the first window, the second window, and this is third window. So here, what the first confirmation, all the parameters are given. Majorly, we will be interested in binding energy and inhibition constant. So here, binding energy is minus 8. There was one molecule, different conformer, second conformer, minus 9.7, third, minus 8.95, fourth, fifth, and sixth. Sixth is minus 8.74. So which is the highest one? We can identify minus 9.3 is the ninth conformer, and highest is fourth conformer, minus 9.7. So it is same as this fourth conformer, minus 9.67. Okay, so we should work with this fourth conformer. Reason is it is the one which is showing highest docking score. So I will select on this. Suppose this will here mention right. We'll click bright complex. Moment I click on bright complex, another will be generated. So this time I will give the name ligand. I will give the name for my interest ligand 1, or let me say ligand Q, and this is for my choice. I'm giving the names, and since it is fourth conformer, so I will give the name ligand Q4 and we'll save it as PDBQT. Okay. So once I will save in my trial documentary, I can visualize it as well. So this is now not required. I will close it. So the job of AutoDock is completed. After this, we will open up our PyMol. We'll Thymol will look alike. Thymol will now function. I can open up my file, this ligand Q4 PDBQT, by simple click and drag into Thymol and it will open. This is how my ligand is docked into the active site. Okay, I can take the pose as well and zoom the molecule like this. Zoom. So it is there. This is whole molecule. I want to zoom to my target. You can see how beautifully it is docked to the site. You can take such pose from any desired angle, present it as well. For the sake of like this is something additionally, so I will delete the selection because I don't require that. It भले ही ligand select हो गया था रहने दो. What I can do, I can go to preset, can select publication. It is now beautifully further. Can go to action, find polar contacts involving side chains. So I can see what are the interactions of this as well because there was certain molecule doing interactions, hydrogen bonding interactions. So these dotted lines are meaningful for this. If we do not want to interest them, then we can delete. This is the one way to deal with the molecule like this. Another way is there is something called leak clip. Where is that my AutoDock files? Close this. I could found as many other softwares also. Uh, one of them is this leak clip. Show it from my this leak plot plus. So this is their leak plot plus. Will is available on internet and through academic license we can work on it. I have already downloaded, so I will show it to you. How we can generate those poses using the plus. So I have click on this, click plot plus, click plus. I will open the PDBQT file, go to browse, go to desktop where I have saved my trial documentary, open it, click on that. I have opened it. One PDB file. Okay, it is there. PDB4 browse. We'll go to trial. In trial, I will open my ligand Q4 PDBQT, which is my log file. And then I will select on run. So it will show my dock compound like this. So you can see the hydrogen bonding interactions with the residues. The labeled residues itself is generated. These are the DNA. This is adenine, thymine, tyrosphotyrosine. This is some other residues, asparagine, glycine, aspartic acid, lysine. So this is surrounded, and this lysine 751 is showing hydrogen bond interactions with this sulfur and uh, uh, here it is oxygen. So this hydrogen is showing the. We can go to this on off, click on hydrophobic interactions. Okay. So these are all hydrophobic interactions by the surrounding residues. So we can click on or off it. Can change the colors as well, depending upon what is the background we require, what is the plot color, etc. Okay, so